Welcome back to Decentralized Application Development Crashcasts. I'm Sheila, and I'm here with Victor. Before we dive in, I'd like to remind our listeners to rate our podcast on whatever platform you're listening to us. Your feedback means the world to us.
Absolutely, Sheila. Your ratings help us improve and reach more developers interested in decentralized systems. Now let's get started with today's topic, P2P versus client-server architecture. We're currently in Chapter 1 of Season 1, exploring the fundamentals of decentralization.
That's right, Victor. And to kick things off, I have a quiz question for our listeners. Here it is. Which popular file-sharing application, launched in 1999, is often credited with bringing P2P technology into the mainstream?
Ooh, that's an interesting question, Sheila. It really takes us back to the early days of internet file sharing. I'm sure many of our listeners who were around during that time might have a good idea. For those who weren't, this application caused quite a stir in the music industry and sparked many discussions about copyright and file sharing. But let's not give away too much. We'll reveal the answer at the end of the episode.
Good point, Victor. Now, before we dive deeper, could you give us a quick definition of P2P and client-server architectures? I want to make sure our listeners are on the same page.
Certainly, a client-server architecture is like a restaurant. You have a central kitchen, the server, preparing and serving food to many tables, the clients. In computing terms, a powerful central server provides resources or services to multiple client devices. On the other hand, a P2P, peer-to-peer architecture is more like a potluck dinner. Everyone brings a dish and shares with others. In P2P networks, each computer or peer can act as both a client and a server, sharing resources directly with other peers without a central server.
That's a great analogy, Victor. So, if I understand correctly, in a client-server model, my laptop would always be a client requesting services from a central server. But in a P2P model, my laptop could both request and provide services to other computers directly. Is that right?
Exactly, Sheila. You've got it spot on. This fundamental difference leads to some key advantages and disadvantages for each architecture. Would you like to explore those?
Absolutely. Let's start with the client-server model. What are some of its main advantages?
Great question. The client-server model has several advantages. 1. Centralized control. It's easier to manage and secure data when it's all in one place. 2. Simplicity. Clients don't need to be as powerful or complex since the server does most of the heavy lifting. 3. Consistency. It's easier to ensure all clients have access to the same up-to-date information. However, it also has some drawbacks. Can you think of any, Sheila?
I can think of a couple. First, if the central server goes down, the entire system is affected, right? And second, as the number of clients grows, the server might become overwhelmed and slow down. Are these valid concerns?
Excellent observations, Sheila. Those are indeed two major drawbacks of the client-server model. We call these issues single point of failure and scalability challenges, respectively. Now let's consider P2P. What do you think are some advantages of this model?
Well, based on what we've discussed, I'd say P2P systems are more resilient because there's no single point of failure. And they might scale better because as more peers join, they also contribute resources. Am I on the right track?
You're absolutely right, Sheila. Those are two key advantages of P2P systems. They're often more resilient and can scale more easily. Additionally, P2P systems can be more cost-effective as they don't require powerful central servers. However, P2P isn't without its challenges. Security can be more complex, as you need to trust multiple peers rather than a single server. Consistency can also be an issue, as it's harder to ensure all peers have the most up-to-date information.
That makes sense. So, Victor, with these pros and cons in mind, how do developers decide which architecture to use for their applications?
Great question. It really depends on the specific needs of the application. Client-server architectures are often used for applications that require strict control over data and functionality, like banking systems or email services. P2P architectures, on the other hand, are great for applications that benefit from decentralization, like file sharing, content delivery networks, and some blockchain applications. Interestingly, many modern applications use a hybrid approach, combining elements of both architectures to get the best of both worlds.
That's fascinating. Can you give an example of a hybrid approach?
Certainly. A good example is Spotify. It primarily uses a client-server model for user accounts, playlists, and metadata. But for actual music streaming, it incorporates P2P technology. When you're listening to a song, you might be getting parts of it from Spotify's servers and parts from other nearby Spotify users who have recently played the same song. This hybrid approach helps Spotify reduce server load and improve streaming quality.
Wow, I had no idea Spotify used P2P technology. That's really cool. Now, before we wrap up, I think it's time to reveal the answer to our quiz question. Victor, would you like to do the honors?
Of course, the application we were referring to in our quiz question is Napster. Launched in 1999, Napster was a pioneering P2P file-sharing platform that allowed users to share MP3 music files directly. While it faced legal challenges and was eventually shut down in its original form, Napster played a crucial role in popularizing P2P technology and reshaping the music industry.
Thanks, Victor. To summarize today's episode: 1. Client-server and P2P are two fundamental network architectures. 2. Client-server offers centralized control and consistency, but can have scalability issues. 3. P2P is more resilient and scalable, but can face security and consistency challenges. 4. The choice between them depends on the specific needs of the application. 5. Many modern applications use hybrid approaches to leverage the strengths of both architectures.
Excellent summary, Sheila. I hope our listeners found this comparison helpful in understanding these crucial architectural concepts.
Absolutely. And to our listeners, if you enjoyed this episode, please visit crashcasts.com and consider joining our Discord community. Your support on Patreon helps us continue creating this content. Don't forget to subscribe and rate our podcast. It really helps us out. Until next time, happy coding.